How's it going, everybody out there in pre-cal world? In this video, I want to be talking about section 8.2, vectors in the coordinate plane. So first we have to understand what a vector is in order to do anything at all. So pretty much what a vector is say we have this guy and he has a bow and arrow and he wants to shoot his arrow. Well, whatever angle and with whatever power he pulls back that bow, he will have that arrow traveling at some angle and with some force or some magnitude. So basically all a vector is something with a direction and a magnitude. All that magnitude means is just strength, like there's a magnitude of an earthquake or magnitude of a volcano or how big something is. So how big something is, how big this is a vector. So it goes from there all the way to there. That would be considered the magnitude. If I define this as vector v, that's a v with a half arrow on top. You read this as vector v, or this would be vector m, vector t, vector, you know I have to do it, vector monkey, whatever you want to label your vector as. As long as you put a half arrow on top, then it is a vector. Your book is going to bold it though. So you will see something like this, and they will call that vector v. You will see a bolded letter, but you will understand what they are talking about, I promise. Okay, but this thing, the length of it, this is considered to be the magnitude. Magnitude. You will see the book write it as absolute value of a bold letter, but really in real life, we're going to write it as the magnitude of that vector. That is how I've always seen it represented in any mathematical context, other than book for some reason, I don't know. And your vector has to start from somewhere, right? The bow and arrow, the arrow has to start from somewhere, so we consider this the initial point. And where it is going to is considered your terminal point. Ta-da! Vectors! Yay! Oh, so pretty. Oh. Okay, in order to represent vectors numerically, they have an x and a y direction, just like everything in real life. Well, actually most things in real life also have a z direction, but we'll not talk about that. So, on the coordinate plane, because we only talked about the x and y direction, these are going to start from the origin. So start at origin. Unless it states otherwise, we're always going to start at the origin for these. So if we have the vector like 3, 4, say, notice these are like greater than or less than kind of looking type things. They just represent vector. So remember, this is a point. This represents a vector. Cool? Cool. Yeah, I understand. So if I have 3, 4, all that means to do is go over 1, 2, 3 in the x direction, 1, 2, 3, 4 in the y direction. There would be how I graph the point. So the vector is just from the initial to the terminal. So from the origin to where the vector is. And you could find the magnitude of this thing by doing Pythagorean theorem. It is over 3 up 4. So the magnitude of this vector is also the same thing always as x squared plus y squared, the square root of it. So you would have the magnitude for that one would be 5. So you'd have 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. Yay. Standard form, same sort of thing. They mean the exact same thing. There are just different ways of writing it. Sometimes standard form is more useful in math, so we have to know both. This is vector I. It is the unit vector 1, 0. This is the vector j, which is the unit vector 0, 1. So notice the x goes with the x value, and the j goes with the y value. Yay, y value. So vector I, vector j, x and y mean the exact same thing. So say we had 3i minus 4j. In order to graph that, you would have over 1, 2, 3, down 1, 2, 3, 4, and you would have your vector. Yay, vector, 3i minus 4j. Alright, so say we're given a problem like this. Find component form and standard form and magnitude of the vector with given initial and terminal points. If it gives you A, it is going to start at A to B. So I know my initial point is A, my terminal point is B, so initial, terminal, yay. So if I were to graph this thing, 2, -4 would be over 1, 2, down 1, 2, 3, 4. And there would be my initial point. Notice that is a point, not a vector. And then I have -3, 2, so 1, 2, 3, up 1, 2, 2, 2, 2. So I'm going from there to there, and I have my vector going that direction. All right, so in order to state the component form, all it is the change in x. So if it went to the left 5 units, it went -5 units. And then check it out, it went up, what is that, 6 units? So 6 units. Also notice from 2 to -3, it went down 5. -4 to 2, it went up 6. So there's our vector. And I will list it as a vector equals that. Okay, and to write it in standard form, all I need to know is that I and j, so -5i plus 6j. Yay! To find the magnitude, Pythagorean theorem, 5 squared is 25, 6 squared is 36, 25 plus 36, I believe, is 61. So the magnitude of vector v is the square root of 61. You can give me that as a decimal to 2 points. It should be 7 point something. I don't remember, but yes. All right, I want you guys to pause the video, write it down, give this a shot. I'm going to pause the video, do the same thing, so you're going to magically see. Don't be frightened, it's okay. So with this, I notice from 1 to 4, it went up 3. From 4 to 0, it went down 4, so 3 and -4. To write it in standard form, use the same thing, but use the vectors I and j, so 3i minus 4j, and then the magnitude, 3 squared is 9, 4 squared is 16, square root of 25 is 5. Yay! Dance party! Alright, so with ones like these, this is pretty simple. All you're going to do is remember that x's go to x's, y's go to y's. So if I have vector m plus vector v, it gives me a whole list of vectors there. Well, I know that vector m is -2, 4, and I know that vector v is 12, 2. So all I'm going to do here is add the x's to the x's, so -2 plus 12 is 10, 4 plus 2 is 6. There is my resultant vector. Yay, let's do some more. Okay, with these, h minus m, so I will have vector h is 0, 2, minus vector m is -2, 4. So when there's a number up front, or in this case a negative up front, I like to get rid of that negative before I do anything else. So all I'm going to do is distribute it to both of my terms in that vector and change it to an addition sign. So if I multiply this negative by both of these terms, I will have 0, 2 plus 2, -4, just so that it makes adding those two things together. You do not have to, but I like to because it helps me get more answers correct. So 0 plus 2 is 2, -4 plus 2 is -2. There would be my vector. Okay, just like if there were numbers in front, all I'm going to do is copy that number in front. 3 times v is 12, 2, minus 2, h is 0, 2. So all I have there, if I distribute the 3, is 36, 6, plus 0, -4. 36 plus 0 is still 36, and 6 minus 4 is 2. Yay. All right, take a second, give this one a shot. I'm going to write the answer. Ready, go! I'm going to beat you. I told you I'd run. All right, next thing we need to talk about is something called a unit vector. All that this is a vector with a magnitude of 1. So let me go ahead and write that real quick. And in order to find the unit vector, you take the vector and simply divide it by its magnitude. So think about this. If you have the vector 3, 4, and you're looking for the unit vector of that vector in the same direction, you know that this vector has a magnitude, let's do this, magnitude of 5. Well, if it's 5 units long and I want it to be 1 unit long, all I need to do is divide it by 5. So then I would have 3/5 and 4/5. Oops, not a parentheses, that thing. But there would be your unit vector. So let's look at an example of this. So here we go. Determine a unit vector in the same direction as this given vector. So in order to find this magnitude, I would have 2 squared is 4, 6 squared is 36, so 4 plus 36 is 40. So I'll take the square root of that. And all I'm going to do is just divide it by its own magnitude. And so I have the vector 2 divided by root 40 and 6 divided by root 40. And there would be your unit vector. Easy as that. Okay, last concept we need to talk about is something called a direction angle, which is basically just whatever direction your vector is going in. So say we have a vector in the first quadrant. Well, this is just like the unit circle stuff, so that would be your direction angle. Yay! If it were in the second quadrant, then your direction angle would be from the positive x-axis all the way around to it. That would be your direction angle. If we were in the fourth quadrant, you would have the direction angle from the positive x-axis all the way around to your angle. That's all the direction angle means. So let's look at it. Okay, so say we are just trying to find the direction angle. Well, I know I can graph this vector to -4. That should be in the fourth quadrant. So to -4, it's down there. And I know for the direction angle, I'm going to need to know the angle all the way around to the angle. Well, notice that is just short of 360 degrees. So if that's almost 360 degrees, I can find what little angle that is inside of there. Because I know this went over 2 and down 4. Well, then I can just say that tangent inverse of 4 over 2. Tangent inverse, 4 divided by 2 is 63.43. Well, if I take that angle away from 360 degrees, my direction angle should be 296.57 degrees. Okay, likewise, -3i and -2j, that should be in the second quadrant. So I'm somewhere over there, where I know I went -3. That's not right. That's not right at all. This should be, oh gosh. Oh no. Oh no. Ignore it. I'm not thinking appropriately. Where'd it go? There it is. Sorry, third quadrant. So you have -3, you have -2. Your direction angle is going to be all the way around to it. So notice that is just past 180 degrees. So 180 degrees is my reference angle. So I can find this again by saying this angle inside there, tangent of it, opposite over adjacent, so 2 over 3. Tangent inverse, 2/3, 3369. And do 180 plus that, because it has gone past 180 degrees. So your direction angle then should be 213.69 degrees. Sorry. I was going to say something. What was I going to say? Man, I don't remember. Well, I think that's all you need to know. Okay, given an example like this, find the component form of a vector with given magnitude and direction angle. So remember, component form, I'm looking for x, y, looking something like that. Well, just thinking about the direction angle for this, if I know that I am in the second quadrant, and since that angle is 140 degrees, the small angle inside my triangle, or the reference angle, should be 40 degrees. So then if I draw my triangle with the right side of the pen, I can find an x direction and a y direction, and I know the magnitude is 6. Well, from there, it's just basic trig. I mean, if you want to find the x, you can say cosine of 40 degrees is adjacent over hypotenuse. Multiply the 6 to the other side, type in your calculator 6 cosine 40, and get that x is 4.596 or 4.60. I will probably write it like that. And notice, since it's going negative, make sure you put a negative in there. So far we have -4.60. And for the y, you can say sine of 40 degrees equals y over 6, so 6 sine 40, 3.86. And again, since it's going positive, it will be positive since it's going up. So 3.86. And there it is. Hopefully this video has been helpful. Please make sure you come ask questions if you have questions. Love you guys. See you in class. Well, bye!